Hi Year 12s. So this is just a short video to follow on what we were doing with limits the last time I spoke to you. So I've got a quick example there. The limit as h approaches 0 of 7x plus h. And if we think about what we were talking about in the last video, then I'm looking at if h approaches 0, then what will 7x plus h equal when h is not equal to 0, but so tiny as it might as well be 0, and the answer to that is going to be 7x. So I treat it like a substitution, but I don't actually do a direct substitution. So I'm going to do that for my next example. Consider the function f of x equals x minus 3 squared at the point x equals 2. Sorry, x minus 3 squared plus 1 at the point x equals 2. The first question is find the gradient of the secant through the point where x equals 2 and x equals 2 plus h. So I'm going to have 2 points, P and Q, and P is going to be when x is 2 and Q is going to be when x is 2 plus h, so it's just slightly to the right of where x is 2. And then my second part is to find the limit of that gradient as h approaches 0. What that's going to do is it's going to give me something which will be the gradient of this function at the point where x equals 2. So I'm going to take those two steps separately. So the first step A, all I need to do is find the gradient of the secant. Oh, this is wobbling. Hang on. That's better. I need to move it to the right. There we go. So the gradient is going to be, what would I normally do for gradient? y2 minus y1 over x2 minus x1. And I'm going to have 2 points. The first point is going to be where x is 2, and then I put 2 into the function and I'll get something. And the second point is going to be where x is 2 plus h, and I'm going to put x is 2 plus h into this function, and I'll see what I get. So I'm going to substitute my x and y values into this. So y2 is going to be, instead of x, I've got 2 plus h minus 3 squared plus 1, and then I'm going to subtract y1, which is going to be f of 2, so that's 2 minus 3 squared plus 1, and then that's my numerator. My denominator is going to be x2 is when x is 2 plus h, and then I subtract x1, which is where x is 2. Now I just need to expand and simplify, so I'll just quickly go through that. So I've got 2 plus h minus 3, that gives me h minus 1 all squared plus 1. Subtract, that'll be negative 1 squared, which will give me positive 1, plus 1, it's going to be all minus 2, over 2 plus h minus 2 gives me h. Let's expand this bracket. I get h squared plus 2h, minus 2h plus 1. And then I've got another plus 1 minus 2 all over h. This plus 1 and plus 1 minus 2 is going to cancel. Oh, sorry, you can't see what I'm doing there. Hang on. Shift some things. There we go. That's all going to cancel out. So then I'm going to have h squared minus 2h over h. So I can take out a common factor of h, and I get h minus 2 over h. The h is cancelled. I get h minus 2. Okay, this at the moment, this is not a limit. This is the actual gradient of the point, the line from the point where x is 2 to the point where x is 2 plus h. So depending what h is, if h is 3, that's going to be the point where x is 2 plus 3, that's x is 5. What will the gradient of that line be? It'll be 1, 3 minus 2. Okay, this is not a limit at this stage. However, part B, find the limit of this gradient as h approaches 0. Sorry, you can't see that. Find the limit of this gradient as h approaches 0. So the gradient I've already found is h minus 2. I need to find the limit as h approaches 0 of this gradient. All I do is I effectively substitute in h is 0 and I get negative 2. So at the point where x equals 2, I've got a gradient of exactly negative 2. My last and quick worked example for you is if I was going to use my CAS to do this. So what happens is if I've got, let's say, this expression, which is 2x cubed h plus xh minus 4h over h, and I want to find the limit of that as h approaches 0. I can simplify that first. You can see that h cancels out, but I'm not going to do that. What I'm going to do is I'm going to put it straight into my CAS. Now you can't see the original equation now, but it's here. Oh, except I've got a mistake. I squared it instead of cubed it, and I didn't go back and change it. I'm going to go ahead because I've made this video twice already. I'm not doing it again. So this is 2x. Let's pretend the equation I've got is, in fact, I can change it on the page. There it is, 2x squared times h plus xh minus 4h. What I've done is I've gone straight into Math 2, and I can see there is a limit button just there. The limit, just press that button, and that brings this up. I needed to then manually enter the h and the 0, and you can see that then I've just entered the expression. Now you can see I've got little times signals in there, the computer version of times. You don't need to do that on your handheld. It's just that when I type it into my, on my laptop, it won't register that xh means x times h, so I've put it in there. But I checked it on my handheld, you don't need to. And then you can see it has simplified that just as though I did take the h's out and it all cancelled out. That's how you do it on your CAS. Make sure you have a practice of that. All right, that's the end of this.